Welcome to this presentation. We are going to be considering the modeling, analysis, and design of this commercial structure. And this is skill building. Alright, so this is what we will be doing in just this video, and then we'll be producing a detailed drawing of this structure. And so I want to urge us to please like this video, subscribe to the Cantilever channel, and stay tuned for more advanced lesson as we get into this lesson. So let us get started. I will be navigating us to AutoCAD, where we have the 2D drawings of this structure. Alright, so here in AutoCAD we have the reinforced concrete columns being set out just like this, and then the total length of this building is 56 meter, alright, 56.075 meter. Okay, so which is too long, and so we have to introduce an expansion joint. You can see over here expansion joint at 31 meter, 31.825 meter. Okay, so here is how this structure actually look like, although this is the electrical aspect of it. Okay, so that is not that concern. So we are going to be exporting all of this now to Protastructure, and then we carry out our modeling successfully. Okay, here is the grid lines being set out successfully just like this. Okay, so for us to do that, at first we need to take all of this 2D plans to the origin here, okay, so that we can be able to see it at Protastructure origin as well. So how to do that? You just have to key in on the keyboard L, which is for line, enter, and then type 0, then key in comma 0 again like this, and then hit on the enter. You see it has located the origin. Alright, so we have to zoom to get to the origin. So here is the origin of this AutoCAD drawing environment. So we just have to make sure that we have a straight line, or we turn up the auto right there to have a straight line and click. Okay, alright, so at this point I highlight all of this, and then you just have to click on the move or copy or M on the keyboard for move. Alright, zoom closer to the plant. I want to be taking this point and this point from here, and then I'll take it to this origin here and click it there. Alright, so delete this line just like this. At this point we cannot convert this file to DSF. Okay, so you have to highlight all of this like this. Okay, and then type W on the keyboard, enter. Alright, so in these provisions you have to locate the directory to save this file. I want to be saving to desktop just like this, and then I key in the name as design. Okay, so I will key in design right there just like this. Take note of this name because we'll be looking for this file on this desktop. Okay, design. Okay, and then the file type, okay, the format is going to be DSF and not DWG, so I'm using this 213 DSF. Okay, so and then I will click on the save options there, and then I click on the OK options. Alright, that file is saved successfully. So let us get back to Protastructure. So I will have to minimize. Alright, so here is Protastructure. We get back to the file menu right there. Click on the new project. Okay, so we will be selecting the code of practice BS810 will be considering in this design. Okay, so we select the template and give it a name. Okay, let's call it a 2-story building 3. Okay, just like this, and then click on the OK options. It's okay, so we are back to the templates that we just created. So you just have to navigate to your building set out over there, and then there you will be able to actually locate this DXF import. Click right there. So in these provisions we just have to assign layer, and then reset layer assignment just like this, and then import type is going to be floor plan. Okay, and so we click these provisions. If you have the the unit to be changed, you can change it through these provisions. Okay, if you click here, you see centimeter, meter, but our plan is coming in with millimeter unit. Okay, the unit of the AutoCAD. All right, so this is how this works effectively. Click on the load DSF. So we navigate to the desktop here. We save the file as design. Okay, we save it as design. Let's look for it. Design. So here is the file. Okay, select it. Click on open. So once you open, it's being open successfully in this provision. Click on the import right there to take it to the modeling environment. Okay, so it's being there on the modeling environment. You can see, click on the close options to have it just like this. So the same place is where it is. That is why you have to take your plan first to the origin for you to be able to place it correctly. Okay, so you can see the expansion joint columns, all of the reinforced concrete columns and the grid lines is being set out. But there's one thing I want you to understand in this. Okay, so if you check the grid lines, you notice the leveling of the grid lines is not in order. If you want to change that, okay, I want to show you how to change that, but we may not honestly look at that very much in this presentation because it's going to take much of our time. But if you want to change it, maybe renumbering it, okay, so you just have to make sure you select it the way you can be visible. Highlight from this point to this point. Now you can see that this is A2. Right click and then click on the property. So in this property, you can be able to now change the A2 to 1, okay, and then A10 to 2, and the rest of that. You can be able to change all of this successfully, both in the horizontal and the vertical axis. Okay, so at this point, we are going to be placing our reinforced concrete beams. Okay, so for us to do that, you go to the modeling tab right there, click on the beams. Okay, so in this beam provisions, we will be considering a beams 2 to 5. All right, so you click into 2 5 right there, okay, by 450. Okay, so 450 just like this. Okay, so you come over to these provisions and then you start to place your beams just like this. So as you are placing the beams, you have to consider your expansion joint. So the beam is going to stop here and then connect it to this, because this is entirely a two structure modeling together. All right, so at this point there is a beam here, so connecting these two columns, you have to just select this beam and get it deleted because we don't need it. Okay, this expansion joint. Okay, select any of these beam, right click and then click on each property and then start to place the other beams just like this. Okay, so for these ones you can just do a sheet over the reinforced concrete column provisions and release your hand. Click right there to have the beam placed there automatically. Okay, click on the, do you want to split the new beams at support? Okay, yes. All right, so it's going to split it and then be able to give us this. Okay, so we are having a support here, we don't need this actually, so you have to delete that. Okay, this one, cantilever beams, we don't need it here. Okay, all right, so having do that, release that one. Okay, having done that, we proceed. Okay, we don't need these beams again. All right, okay, so select any of the beams again, right click right there and then pick this point to this point to connect this, pick this point to this point to connect this. All right, we also need to connect this just like this. Okay, the same thing applicable these provisions just like this. We take it all the way to where we have the expansion joint. It's going to stop there and then connect to this other one. Okay, just like this. Okay, so we connect it to these other beams just like this. So this is the modeling of the reinforced concrete beam of the first floor. Okay, so we connect this. And then connect this as well. Alright, so you proceed, right click again, and then we need to also connect this up to the expansion joint columns. Yeah, after which we also do that these other provisions like this. Okay, so we proceed and then we complete these remaining two provisions. Sometimes you have to zoom closely to make sure you pick the exact point just like this. All right, so now you can see we have successfully placed the first floor beams. So the next thing we'll be looking at is the slab. So in this provision, this is a staircase provision, so we wouldn't need beams. Okay, but we will be placing beam that is going to be a different depth of a beams. Okay, so at this point we navigate to the building modeling tab. Okay, the reinforced concrete slab, and then we'll be having the thickness to be 150 millimeters. Okay, so and then for the load, we'll be having our dead load. This dead load consists of the partition load. This is an additional dead load, partition load, the load for the tiling and the decorations and all of that. Okay, so for the main dead load, you can see it over here 3.6. okay, for the life load, we'll be considering the life load for a commercial structure. Okay, so we can use 2 kilonewton per square meters. All right, but I will want us to use 2.5. I'm looking for 2.5. Okay, this one I'll use 2.5 for schools. Okay, so at this point you just have to keep placing the reinforced concrete slabs just like this. All right, so after inserting your slab successfully, just like this, okay, you just have to click on the closed options here to have this dialog closed. So the next thing you need to do, let's just navigate to see the 3D of this structure at first. Okay, so we have something of this kind. All right, at first. All right, so at this point we want us to be creating our stairway. Okay, we want to create our stairway and see how we connect the stairways to the to the first floor right there. Okay, so we navigate to the plan view. Okay, we navigate to the plan view, right click and then click on this to get to the plan view right there. Okay, so at this plan view now, what you need to do is we'll first of all set our story height. Okay, so for us to do that, select the stories, right click and then click on the edit story. So in this edit story, you can see the default story used to be 3 meters. Okay, so we can go by that. Then for the foundation, then it's a 2-story building, so we can just take it to be 1200 right there. Okay, so we'll go by this story height, which is the 3 meters. Okay, but since it is a school, we can make it 3.3 right there. Okay, so this is 3.3. Okay, so after having done that successfully, you click on the OK options. So we have set the story yes options right there. Okay, so we make progress. At this point, we will be placing a landing here. We'll be placing a landing here. So a landing is going to be a reinforced concrete slab of thickness 150. So we will double click right there in the slab provisions and then click in 150 right there. Okay, so it is a landing for staircase. So we will be using a dead load, additional dead load of 2 kilonewton, and then we will be considering the post load. Let us just make use of 3 kilonewton right there. Okay, for the landing of the stairway. Okay, so after we click here to have the landing just like this. Okay, so having the landing like this, we need to send this landing down. Okay, because this is on top of the columns, so we have to send it down. For you to send it down, you go to the general tab right there. So here is have a relative level, so we need to send it down like 1500 millimeters. Okay, which is okay 1650. Let's take it to be 1650. Okay, so it's going to be intermediate at the center of the height of the structure. Okay, so 1650, we are sending it down, so we are supposed to prefix it with minus, so add a minus and click on the update right there. So after which, let's close this and check that if it is actually correct. So we navigate to the 3D right there. Check this. All right, so you can see what we have there is actually correct. Okay, so at this point we will move ahead to the plan view. We want to be placing the reinforced concrete slab as well. Okay, for the stairs. Okay, so you click on the slab right there. Okay, check these provisions, make sure you have it to be 175 this time around. 175 should be the thickness. Okay, so and we will have to actually place it here, and then as well we place it here. Okay, we also need it here, that is going to connect to the first floor right there. So we click on the close options. Now we want to set the inclination of these slabs. Okay, but by then let us look at some things. Okay, so let us get to set this slab so that they can be also be visible. But before then, we will have to incline this slab. Okay, so for us to incline this slab, you have to go to the modeling tab and then come to where you have plane definitions. Okay, so at the plane definitions, you click on it. So once you click on the plane definitions, you select this to have a plane 1. Okay, we also have to select this. This is going to give a plane 2, and this is going to give a plane 3. Okay, so we have plane 1, 2, and 3. So now we are going to be editing this planes successfully. All right, so now we have plane 3. So at plane 3, we want to anchor this to the 0 level. We want to anchor this to the 0 level. Send this to the height of 1650. Okay, so how do we do that? At first, you will need to actually pick this point. We are having the Z0 here, Z1, Z2, and Z3. Okay, so you can see. All right, so what we need to do now is we want to be taking this Z2 to this point, and then we have here to be Z3. Okay, so for the entire slab like this, we are going to send it to that same level of this slab. Okay, we are sending it to the same level of this slab at first. So let's close this. All right, and then let's select this slab, select the reinforced concrete slab. After having that selected, you can just right click and then click on it properties, and then the relative level you have 165. Okay, so you click on the update. So this one has gone down. You can see it has moved down. Okay, to that level of this particular one. The same thing is applicable to this. All right, so you right click and then click on it property, and then sorry, that is the plane. Okay, you need to select the reinforced concrete slab, right click and hit properties. Okay, so in these provisions you have 1650, just like this. Click on the update and then you close this. Okay, so looking at what I've just done, let's navigate to the 3D. Okay, so that is how it works. You can see in the 3D you are not having, okay, this sent up is supposed to be prefixed then with minus. Let's do it in the 3D right there. So we can select this, right click and then click on it, property. So supposed to prefix it with minus, prefix it with minus, update like this. Okay, that is what I meant, just like this. Okay, so we prefix this with minus as well. Okay, just like this, update. Okay, close this option. So at this point we can now be able to, you know, send this send the plane definitions just as I've explained successfully. So you just have to select this. After having this selected, let's go to the plan view of that. So at this plan view, having our plane definitions selected just like this, you just have to right click and then select the plane definition, right click and then select the property. In the property of the plane 2, we need our Z2, okay, to be at this point. So we need to place it here and then update it to take this to that point. That is it. Okay, so this 2 point, we will be sending this 2 point down at a length minus 1650. Okay, so this is point 2. Okay, point 1 and point 2. So we put in minus 1650 right there. Sorry, this is another thing. 650 is what we actually intended. Okay, just like this. And then over here we still have minus 16, okay, 50, just like this. Okay, all right, so we click on the update right there to update that these 2 provisions. So this is at 0. Okay, we are not sending this side. This side is at 0, this side goes down so that we can have the slope we required, okay, for the stairway. All right, so at this point let's come over to this level 1. We are already having 3 here, we are having 2 here, but we didn't want 3 to be here, we want 3 to be up there. Okay, so what we did do is to select this and then get the plane selected on its property. Okay, so for this 3 now, picked it and take it to this point and then click on the update to move the 3 right there. Okay, so for the here is 2, we are having 1 here. Okay, so you pick the 1 right there and then we take it to this point. This side has not been moved. Okay, so all right, select it again and then its property, you pick 1 right there, take it to this point and then click on the update to take the 1 there. So you can see, so at this point we are sending this 1 and 2 down, okay, as well. So if you have any question, you can drop it at the comment section. So we have minus 1650 right there. You come over here, you have minus we have a minus 1650 right there. Okay, just like this. Click on the update and then click on the you see it's been updated, minus 1650 millimeter. Click on the closed option. So we are now having this set successfully. Let us set this plane as well. So for this plane now, plane 3, you just have to, first of all, we need 3 there. We are already having 2 here. Okay, so we need to send this 2 down. Okay, so for us to send this 2 down, you have to enable the properties of the plane 3. So this is the property of the plane 3. We are sending 2 down, the same value. Okay, 1650. All right, so at this point you have the same thing, 650, just like this, but you have to prefix it with minus, just like this. Click on the update options, just like this. Okay, so we have this set successfully. Let's close this. Okay, all right, so we have to navigate to the 3D to actually see what we have done, and then we try to incline the plane successfully. I hope you are following the presentation successfully. Don't forget to like and subscribe for this on this channel. Okay, so I will navigate to the 3D. Okay, so here is the 3D. This is what we have. Okay, so at this point, to incline this now, we just have to let's take this up. Okay, so we have our planes 1, 2, and 3. So select plane 1 right there, right click, and then click on the move plane members to plane. Sorry, move members to plane. Click right there. So yes, options right there. It's going to move. So you can see plane 1 has been inclined already. So that is how it works. Same thing applicable to plane 2. Right click and then select this move members to plane. Right, this and yes, options. You have that move successfully. So for the plane 3, you have to do the same thing. Okay, but it is going to take a very long distance. So let's do that. Right click and then click on the move plane members. Yes, options. So this has been moved. Okay, so you can see it has been moved successfully. Okay, but this move alongside with the reinforced concrete column, so we wouldn't want that. So what do? All right, so you select the reinforced concrete column, right click, and then click on this property. So this property dialog, you come over to where you have the 3D. So this is the provisions, change it to 0. Okay, and then you can remove the plane right there, put here 0 or remove, make it empty, click on update. It's going to take the column back to its original height, you can see. So the same thing applicable in these provisions. Click here, and then come down to the 3D right there, and then you change that to 0, and then click here and delete that P3, which is the plane, and then click on the update to have that up right there. So okay, this is what we actually intended to have, right? So the next thing we are going to do, we will be now considering how to set this so that this can be visible. You can really see the slab very much. Okay, so you see the slab looks very transparent. So for how to do that settings, you have to go to the modeling tab, come to layers and colors right there. All right, so in the layers and colors properties, these properties, you will have to navigate to where you have reinforced concrete slab. See slab ash right there. Click on this slab ash. We want it to be more darker, so we use that color. Okay, click on the OK options to have it just like this. Okay, so all right, so this one we have, we need the beams at this point. Okay, below 1350 we need some beams. Yeah, okay, and beams also there. Okay, so for us to put that, you have to navigate also to the plan view. Let's get to the plan view. Okay, so or we can do that also on this 3D view, but that will be fine. We'll do it at the plan view. So you see, if you notice, these columns are also being affected by the plane, so you have to remove the plane constraint from the columns successfully. All right, just like this. You click in 0, and then here you delete that. Click on update. All right, just like that. The same thing applicable to the. So having done that, let's get to the plan view. We need a kind of a cantilever slabs here, so let's go to the plan view. So we navigate to the plan view of this project. Right, so and then in this plan view we have we need to have a cantilever here. Okay, a cantilever here. So for us to do that, you have to navigate to reinforced concrete slab. Again, the modeling tab, click on the reinforced concrete slab, a cantilever, and then the cantilever slab is going to be 150, just like this. Okay, come over to this position where you have load. Okay, and then or you can the same thing, use the property of this existing slab, slip that so that you don't need to be setting the loads again. Okay, so all of these things have been in place. Okay, so after having gotten that, so the insertion point is going to be peak point. Okay, we're having a peak point insertion point for this slab, but by then we need to be having a beam to support this slab. Okay, we need to have a beam to support this slab, a cantilever beam, so we have to close this at first. So at this point here we'll be having a cantilever beam, so we will go to beams, or we select any of these beams, then click on each property just like this. Okay, so the depth of the beams is supposed to be the depth of the slab, so we wouldn't want the beams we are going to have here to be bigger than the slab. Okay, to be having more depth than the slab. It's supposed to be 150, so if you are adding 150 here, okay, to be the depth of the slab. Okay, so 150 now, you are left with 350 plus 200, you'll be having 675. Okay, so this provision will be having 675. So this is a kind of a concealed cantilever beam. So we are going to pick it from the point and then take it over to the point, and then we'll be having something like this. This is a concealed cantilever beam. All right, concealed cantilever beam. All right, so I mean, understand that we close these provisions now. Now we want to place the slab. So the same thing we having this side, because we having slab in both sides. Concealed cantilever beam over here. So we placed it here. Concealed cantilever beams as well. So close this. All right, so having done this now, what you just have to do is we select the slab we are having here, and then right click, and then get the slab selected, right click, and then its property. At this point we are going to be placing it in this provision where we have where we actually have our intersections of the grid lines being bound together. So just like this, you place the slab like this, and in these provisions we're going to use another pick point options so that we can be able to select it successfully. We'll pick the first point, pick the second point, pick the third point, pick the first point, and then we'll place the slab just like this. The same thing applicable here. You have to clear this point you pick first, clear it, and then you pick a new point. Okay, so we'll be having here to be a 1 point, second point, third point, and then we'll have here to be the first point to have this slab placed just like this. So let's look at this in 3D. All right, so right click and then click on the 3D right there. So you will have something of this kind. All right, we'll have something of this kind. So now we want to be generating stories. by then, before then, we'll be setting story. You know, this is just a two-story building. Okay, two-story building. So let's us generate story. After inserting story, so select this, right click, and then come to the insert story right there. Since we are considering two-story building, we are going to be having 3 plus the roof 3. All right, so we click in 3 right there. Click on the OK options and yes options. Okay, so now we need to navigate back to the populated story, which is the story 1, and then we will now get back there to generate the stories up there. Okay, so we will click right there, right click, and then click on the generate stories. Okay, so at this point we are targeting story 2 at first. Okay, so we are moving everything from story 1 to story 2 right there. Okay, so and then we click on the OK options right there. So it's going to move up, okay, just like this, as you can see right there. Click on the close options. All right, so you notice that everything is being moved together, okay, including the stairway, as you can see, it's being moved to story 3. All right, so once you land here, you want to go up, you need to come over here to take it up to the next floor. Okay, so that is how it works. As I said earlier, I said we'll be having a beams here that will receive this inclined slab, okay, for the stairway. Okay, so also we will be having beams at this point, story 1. So you navigate to story 1 right there. We need a beam here that will connect this point and this point. Okay, all right, so because this is going to rest on the beams. Okay, so that is what we are going to be considering. So we will navigate to the plan view of the story 1 right there, just like this. We can still put a fix it while on that provision on that view. So and then you click on that property, and you'll use the property of this beam. So I will need a beam here using that property. So we have something like this. Okay, so we still have a beams that will run from that point to this point, just like this. And then we have another one here. Okay, please don't forget to like and subscribe for this channel. Okay, and then we make progress. So after having select and inserted the beams right there, what we need to do is you close this right there. Okay, let's check it in 3D. So in 3D, we really having something of this kind, which is what we actually expected. So the same thing applicable, we need to be having a beam here, and this beam is going to be called a ground beam. Okay, we need to have a ground beam here. Okay, so for us to do that successfully, if you check very well, you notice that this is too stiff. It's not gentle. Okay, but this is just for the sake of these presentations. Okay. Okay, but in a normal condition situation, this is we are supposed to shift this a little bit away from this point so that it can have a distance and then be gentle enough. Right, so for us to add the beams, we need to navigate to the story 0 right there. So click on the story 0. At this point we'll be having a beams. Okay, so it's going to be more like a ground beam. So click on the beams, then you have the beams to be 225 by width, and then the depth you have it to be you can have it to be 350 right there. Okay, so after which you are placing it from this point to this point, so it goes down direct to the floor. So you need to take it up. Okay, when to take it up, come over here, these provisions, you need to go up by we have the beam depth to be what, 350. Okay, 350 minus 1200, you will be having like we'll be having like 850 right there. So let's key in 850. 850. You click on update. Let's see what happened. That is it. Okay, so the same beam we are going to be having also in these provisions from this point to this point, and then you have that. Okay, so now the purpose of this beam is to receive this stairway. Okay, so over here we are supposed to also have a beam that will connect this point and this point. Okay, so that we are going to place it on the level 1. So we have to navigate to level 1. So expand this and then reduce that and navigate to story 1 there. Okay, so at this point we'll be having the same beams. We click on this, right click on each property of that beams, and then we are going to be placing the beam, sending it down. So come to the 3D, then these provisions will be having minus 1650. Right, you have the same thing there, minus 1650, just like this, and then we are picking this point. Pick this point, you see the beam goes down. You can see, also place it here, place it also here, and then we also need to have it there. Okay, That is how it works. Click on the close options. All right, so you can see it now. Everything is fine. So at this point, we are to get to the roof, and then for this reinforced concrete members, this one we want to make it to be slender. Okay, it's not going to be bricked. Yeah, so it's going to be slender. All right, so we will be looking at that later after we must have generated all our story. So we have gotten the story 2. Now we'll be getting the last one, which is the story, the roof level. Okay, so for the roof level, what we're going to do is we are going to actually navigate to the stories, right click and then click on the generate stories. So in this generate story options, from level 2 we target level we are going to target level 3 right there. So at this point we don't need slab because it is the roof level. We don't need slab, we don't need we only need beams. Okay, we only need beams and then the columns. Okay, so click on the OK options and yes options, and that will be generated successfully just like this. Okay, so now we are having the roof beam just like this. Okay, so you will notice that we still have this because we include slabs, so we need to delete this again because this is the last floor. Okay, so we delete that. Yes options to delete that. Then you have to also delete this one just like this. Okay, all right, so having done this successfully, we need to also delete this one just like this. All right, so as I said earlier, I said these columns, the one here is going to commit, it's going to be connected directly to this one that has beams, braces it. Okay, so we need to delete this one, remove this, remove this, remove this. Also you have to remove this, remove this, remove this and this. Okay, after you have that removed, click on delete and then OK options to get that deleted. Okay, all right, so at this point in time we are going to be selecting these ones. You see these ones that is standing alone, we select this one, hold the control key so you can select multiple of it like this. Can you rotate it so you can be able to see what you're doing? Okay, like this, right click and then click on its properties. So in this property dialog where you have lens story 1, you need to select it and then key into right there. Okay, so you key into, click on the OK options and then everything is being adjusted successfully. Click on the closed. So you have that. This one is not selected, it wasn't selected. Okay, but the one that was selected has been adjusted, you can see. So pick this two down that is not selected, then right click and then you will have to click on the properties. So you have to key into right there, click on OK options and then it's closed. All right, so having done this successfully, the next thing we'll be doing, we'll be connecting the roof beams to these columns right there. So we navigate to that story, which is the story 3. So you have to minimize that and then be able to navigate to story 3 plan level right there. So at this plan level, we have to be connecting these columns together. So you select any of these columns right there, right click, and then you have to just connect all of this just like this. Okay, do the same thing here. All right, so we can now connect this just like this, and then we also connect this. All right, so we close this. Okay, so having done this, we can now navigate to the 3D to look at it. All right, so we now have something of this kind. Okay, now for the wall load, the wall loads is going to be on the first and the second floor beams. Okay, so for us to key in the wall load, we can do that in this 3D, but by then we have to save this project. And at this point, I want to ask us to please like the lesson, like these presentations, click on the like button there, and then subscribe to this channel, as we will be bringing to you useful content of this kind. So you select this, right click on that, and then you will have to click on the properties. Sorry, you have to close that. We are applying wall load, so we have to navigate to edit wall load right there. So 225 blocks. The unit weight is 3.47. The height we are using is 3.3. So you key in 3.0 right there. You ask me why is it not 3.3? It is because we have a beam depth right there. Okay, so we have to also key in 225 here. All right, so you have something like this. Okay, just click on the okay options. So to have our wall load just like this. Okay, so having the wall load just like this, we need to apply this wall load to almost all the beams, and there are some beams that is not supposed to carry the wall load. Such a way, so such beam are these ones that are at the veranda, because here is a veranda. Okay, so but we'll be applying to all. Okay, for the sake of unforeseen circumstances. Okay, for you have to select the first beam, come over to this provisions, scroll down, and then hold the shift key and select the last beams right there. Sorry, it is selecting the first floor. The roof beam is not the roof beam, so we need to navigate to the first floor. We are at story 3. Go to story 1 like this. Expand the beam content, select the first one, scroll down to the last one, hold the shift key, select the last one, and then right click, and then you have to paste the copied wall load, this one, and then give the program some time. It's going to paste. Right click and do that again. You have to see sorry, let's do that again. Let's select that, select this beam, right click, and then you need to copy wall load. After you get that copy successfully, you now have to scroll up, select the first beam, scroll down, hold the shift key, select the last beam, right click. This time around we see paste copied beam load, yes options. So you see that paste successfully. Okay, you have something of this kind. So we have to navigate to the story 2, so we repeat the same thing. So you minimize this, navigate to the story 2, and then expand this, select the first one, or the shift key, select the last one, right click, and then paste. Just like this. So you'll be having something of this kind, just like this. So we have fully loaded the structure like this. Okay, all right, so the next thing we will be looking at is we are going to be adjusting the roof beam. We are going to be adjusting the roof beam. So the roof beam is having a sections of 225 by 550. If you check the property, so what do you want it to be such, we want to adjust it. So we will navigate to the roof beam, which is the story 3 right here on the structural trees, then enable the roof beam right there, expand it, where select the first one, scroll down, hold the shift key, and select the last one to get all the roof beams selected. So right click and then click on its properties. So in this property dialog, select this where you have the height, which is the edge, and key in 350. So to not to waste reinforced concrete. Okay, so give it some time. It's going to be adjusted from 450 to 350 successfully. So having changed the roof beam section successfully to 350, you just have to click on the close to close this summary table dialog, just like this. All right, so everything is done now. The next thing I wanted to show to us, although it is most important when you are designing a high-rise structure, is to inch the reinforced concrete beam to the column, or what we call anchorage. And so I will be demonstrating that now. So I will navigate to the plan view of any of this floor. You are supposed to inch all of the floors, right? So let me navigate to the story 1 right there, and then I will right click and select the plan view of story 1, just like this. So in this plan view, you will notice this beam is a continuous beam, all right? And so in the directions to the left hand side, you see it is not continuous, but in the direction to the right hand side is continuous. So you are supposed to inch this side that is not continuous. And how do you do that? You have to just select it like this, right click, and then you come down to where you see object beam end conditions to the left hand side, click right there, and then apply to selected beams, just like this, and then you will see a red dotted point here, which means this beam is being anchored to this column. So this is what you are supposed we will be doing to all of the beams that are discontinuous. So this time around you go to the right, so it can apply it to this beam and this column successfully. All right, so having done that to all of the structure successfully, this time around let's navigate to the 3D view. All right, so yeah, the 3D view of this structure. Okay, mind you, we have a expansion joint here. You can see it here. So this structure is set for analysis. Okay, so I just leave this roof, this load applications wall load here. But if you really want a wall load here, because here is supposed to have some wall load, although not all the provisions supposed to have wall load. So because these places are sit out, okay, so you can also select it and then right click. You can be able to select delete wall load. Once you select that wall load will be deleted. Okay, just like this. Okay, see, there is no more wall load there. Okay, so you can select multiple of that and then delete it by holding the control key. So you can select all of this just like this. All right, you also select this. So in your design of your any reinforced concrete structure, okay, this provision is supposed to have a wall load. Okay, so let's only select it again to deselect that. So we'll be deleting all of this. Any of your structure that you are to design that that the beams doesn't have a wall load, you just have to carry out this process. You select the delete wall load options. Yes, options. Okay, to get that deleted. All right. So another thing that we're showing to us is all of these structures are the windows by the side. So if you want to open the window, this is what you do. Okay. For me, I don't normally like opening a window in the wall load. Okay, because I design for the worst conditions. Okay, that is why I leave all the wall load being closed. Okay, so if you want to open a window in your own case, you can select any of this wall load like this, right click, and then you navigate to edit wall load right there. So in the edit wall load dialog, you can come to this edit openings. Okay, so in this edit opening, click on add. So it depends on the length and the width and the height of the window. So from the ground level, you have it in this Y provisions, which is the window sitting 900. Okay, then maybe the height of the window could be 1.2. All right, what are that 200, and then the width could be also 1.2. I just want to show you how to open a window just like this. So you click on the OK options to open the window. If maybe the window there is a two windows in one wall, the two window in one wall, you have to take note of the the length of it, so you can still add another window. You can see it's overlapping the other one, but what you just need to do is to come to this x-axis directions and then be able to do it from 2 meters, let's say 1 meter. Yeah, okay, so you now have this one shifted away from this original one. You can now begin to adjust this one to fit. Okay, so what we need to do in this one, that we have the x to be 3 meters, you can just make it maybe 4 meters. Okay, 4 meters right there to shift it just to other directions, and then you can now adjust the height of the window, and then you also adjust the width of the window successfully just like this. So you have a window on this wall. Okay, then you can see the window settings difference from this one. This one is 900 while this other one is 1 meter. So you can now change the window settings also to have the same level if you want to actually place a design window for your walls. Okay, so this window you have had it now as reduce the wall, the wall load, okay, that is coming to the beams that is actually carrying this wall. Okay, so you click on the OK options and then OK again to have these windows open just like this. So this is what you will do to all of the wall that has a window successfully if you actually want to open window in your structure. Okay, but in my own case, I don't normally like opening window. I design it for the worst conditions, just as I said earlier. So let's make progress. So having done all of this, you just have to save the project. So we have to now be moving into how we can carry out the analysis. Okay, before then we need to generate loading combinations. Okay, so you go to loading right there and then click on the load case and combination. So if you check in these provisions, you will notice that here is empty. So you click on loading generator. So once you click on loading generator, we are dealing with only vertical load and not horizontal load. So we will be considering only vertical load. We are not designing for wing load. If you are designing for wing load, you can come to this horizontal load and then you can be able to select wing load. So it will apply to the structures. Okay, so since the structure is only concrete, you cannot use this create difference combination for steel members and for steel member design. Okay, otherwise you can click here if it were a combination of concrete and the steel. So this is okay. Click on the OK options. All right, so we now have our loading combination generated just like this. Okay, after which click on the OK. All right, so if you want to have a personal training, okay, with us, you have to check the link in the description of this video to reach to us for a personal training. But I'm trying to explain this presentation in a detailed way that you will understand. But if you have other complex structure to design, you can check the link in the description of this video and then reach to us, and then we will be happy to assist you. Okay, and also if you want us to check your structure for you, fine, we can also help you to do that. Let us make progress as we proceed. Don't forget to like the lesson. Don't forget to subscribe to Cantilever channel, please. Thank you. Okay, let us make progress. This time around, we'll be navigating to the analysis tab right there. So you see analysis has not been done. Okay, so we are going to be looking at static analysis. We have finite element flow analysis, and for the sake of this lesson we'll be looking at static analysis. So we'll click on the building analysis right there. So in the building analysis, the first thing we'll be looking at is the project parameters. So under pre-analysis tab, okay, project parameter, where we have the code we are considering in this project here. Now is the foundations, okay, have allowable stress of soil. So for the sake of this structure, we'll be looking at 140 kilonewton per square meters. Okay, so you now come to title. Here you key in the title of your project. Okay, so made by Cantilever. Okay, so you can just also key in that. All right, and then you fill all of these provisions. Okay, so for here the title of the project, okay, you also fill it in. Yeah, it's very important when it comes to creating a calculation sheet. Okay, but all of this can be edited later if you did not add them. Okay, click on the OK options. And the most important area there is the soil bearing capacity that we have changed successfully. Okay, so after which you now come to where we have this model options. In these provisions, we don't have anything to change there, just leave here at default. Okay, so we go to the analysis tab and then click on the analysis. At this point, we need to check the structure first if there is any error in the structure. So you click on the check right there. So after which you have the building model check dialog, and then you click on the start right there. And then if there's any error in this model that you have made, you see it here. Okay, but if there's no error, you just have it to be a 0 error. Okay, so you can see the building model check completed, number of error 0. So we don't have any error in this structure. At this time, we have to close this now. And then we'll proceed to analyzing the structure successfully. So you click on the building analysis. So in these provisions, it depends on how you want to analyze your structure, whether you want to analyze at the same time design. Okay, so if you want to analyze at the same time design, fine, you have to check these provisions. You don't have steel member in this structure, so it's only concrete. Okay, so you have to check here. Checking here simply means you have asked the program to analyze the structure and as well design the structure successfully. Okay, but if you did not check here, you are telling the program to only run analysis on this structure that you are going to design it later. Okay, so which I will explain to us in a few minutes. So let us check it so that the program will analyze and design as well. So you click on the building analysis right there. So you just have to give this program some few seconds to run this analysis very fast, and then it will complete this analysis and as well design the reinforced concrete members, both the beams and the columns successfully. So let us just wait for some few seconds. So now the building analysis is completed. So you can see the summary of reports, relative story draft, certify the limit. You can see, so you click on the OK options and then you click on the OK options here. All right, so this is going to actually try to open the analytical model. Okay, it's going to open the analytical model, which it has opened it for us. Now you just have to click on the close. If you observe here, analysis has been checked. Design, you can see. Okay, so click on the close options right here to close it. Then you will now have this. Okay, see what you have. So this is the analytical model. Okay, in the analytical model, there are some things. If you want to view the contour of it, you can't, or you want to see the displacement, all right, of this, you can just click on this displacement. So once you click on the displacement, and then you will have the displacement of the forces as well as the moment successfully, and then you click here to have the moment diagram. Okay, the bending moment diagram. So you can see over there, and you can actually use it to select M33, which is actually the bending moment diagram, and then you can see it just like this. All right, so you can as well check the shear force, okay, of this structure. Okay, so select them once, and then you give it some time so you can see the shear force. So these are the things you can actually add to your report successfully. All right, so if you want to check other contour, you can select in these provisions and click on this contour here. So it's going to grid and contour this slab mesh successfully. So give it another looks. Okay, so you can as well be able to come to this solid model, and then once you come to the solid model, if it is being activated, the solid model will actually show us the solid aspect of this structure, which you can see here. All right, so it is being activated. So you check very well. You will now see the real thing that you have done so far. Okay, so these are the things that you may want to add to your report successfully. Okay, so after this is done, you now have to get back to the real model. Okay, you can get back to the real model. This time around, we want to be checking the beams and to make sure that they have passed design. So if you select the beam, right click and then click on the ROC beams. Let's check active story. Okay, so you see some of the beams are actually fed and many of them as past design, so you can actually select them. Like this one, the U ratio is more than 1, that is why it is fair design, so you can actually check that out and then you check what is the issue, what actually makes it to fair. So you will notice that you can also recheck it and redesign the beam successfully. And you can see a bigger reinforcement being selected here. Okay, a bigger reinforcement is being selected because we did not select a reinforcement for this. So you close this by clicking on the OK options and then close this. Okay, we shouldn't have been having 32 by 32 right there. So let's not go back to the design tab and then okay, let's go back to the analysis. Let's check the analysis. Go to the building analysis again and then come to this material, click on this edit material. So in this edit material dialog, for the columns, the strength we'll be using, this is okay, all right, for all. So let's apply it to all. Then we need to select we need to also select the grade. This grade 410 is okay. So the rebars, now we need to remove some of these rebars. We are choosing for column 16, rebar size 16, and then we use 25 maximum, but we also have 20, 16, 20, and 25. We won't have 32. Okay, so that we will not be seeing 32 in the design. Okay, so then for the walls, we don't have wall in this structure, so let us not bother about that. Then for the what's that, the beams, okay, for the beams we can't have 10, we can't have 13, we need 16, we need 20, we need 25, then we can't have 32 right there. So click on the OK options. All right, then for the reinforced concrete slab, okay, for reinforced concrete slab we can have 10, we can have 12, and then 16. That is it. All right, remove other ones, click on the OK. So then for the links, okay, we can have links of 8, we can have 9, we can have 10. We don't want to have 13, so remove the rest of this. Okay, just like this. Click on the OK options. So now we have selected all of these rebars for the structural members. You can go to the foundation floors. The foundation floors, okay. Also check the rebars. We don't need, we can use 12. We don't need 13, 16, and 12 is what we actually wanted. It's just a 2-story building. Okay, so we have this. Click on the OK options, and then finally OK again. Click on closed. This time around we save the project first after having set the materials successfully. Then we want to be designing this building again. So look at what we do, but this time around we are not going to pass through these provisions. We are going to be designing it individually, batch by batch. So let's design all. Okay, so this is all the beams in the structure. Okay, this is all the beams in the structure for both story 1 and story 2 and as well as story 3. All right, so we'll come to this batch design mode. Click right there and then click on select bars, okay, and then click on calculate. It's going to calculate and select bars. If for instance you have designed before without checking that the program should analyze and design, this is where you can come and perform your design. Okay, if the program was only analyze the structure for you, use analysis tab without checking the design, okay, you come here to carry out your design successfully, just as I'm doing right away. So let's wait for it to design all the reinforced concrete beams in the structure successfully. So the design is done successfully. So click on the close options to close it. Now you can see all of the beams has been reset and been designed successfully, none as fed design. Okay, so you can see the U ratio is now being okay and well calculated successfully. Okay, so we close this dialog and then we'll do the same thing to the reinforced concrete column. So select the reinforced concrete column, right click, and then you come to this ROC column/wall design. For all, this is for all the structure, but if you select this is for the active story. Okay, so you select for all the structure, that one. So you notice that none of this is being designed. Okay, you can see section insufficient. So at this time you have to come to column design dashboard, click it once and then select all bars using these provisions and then click on the calculate. Then you give it some time too. It's going to calculate 180 columns that are in the whole of the structures from both first floor, second floor, and the roof. Okay, so just some seconds, the design is going to be successful. All right, so process completed. Click on the close options. To see all the columns are being designed, and then the links is why it's at spacing 175. You can see there, and then we're having still members, okay, to be 4x16, okay, and then we have some columns to be 4x20. You can see over there 4x20. There's some even column that's carrying 4x25. All right, so you have to take note of all of this column, and then we see this column is actually failing. As you can see, the U ratio is actually more than 1. Okay, so once the U ratio, utilization ratio is more than 1, it simply means it exceeded the limit, so it's going to fail. The structure, like the particular structural members, is being stressed up. Okay, so it can't withstand the load at that particular point. All right, so what you need to do to this one now, you have to check what is the problem. But let's scroll down and see other ones if they have successfully passed. This one too has failed, okay, not as a result of U ratio. Okay, so you scroll down, this one too is having issues. All right, so all of these columns that are failing right there, let me maximize this. Okay, all of these columns are failing right here. Like this one, first click on the interactive design. After being selected, you have this. Okay, so you now want to know what is actually making this to fail. So we click on the reset bars, this one, okay, and then click on the interactive design right there. So you see what I'm saying, the warning still bars are not being selected. Section size is insufficient. Okay, so section size is insufficient. You can see it here. Click on the OK option. So what you have to do is to increase the section. Instead of 225 by 225, you can take it to be 225 by 300. All right, and then click on the update. So it's going to adjust it just like this. Okay, then you have to go back, reset the bars, and then click on the interactive design again. So and you can see here section size must be increased as well. Okay, section size must be increased. Click on the OK options. Okay, but even at that, it seems this has passed the design, but it's asking us to increase the section size. Let's click on the OK options and see. You can see it has passed the design, and then the U ratio is now 0.8. Okay, so that can actually go. You have 4y20. All right, 4y20, 2y20, and 2y20 again, and then you can see the links there. All right, so you come down to this one that also failed, and then click on the interactive design. Okay, so let's check what is the issue by clicking on reset rebars and then click on interactive design. So you see they said the steel ratio limit exceeded, so click on the OK options. So section insufficient, that is the issue. So the same thing that happens to the other one. So this time around, let's change from the B1 to the 300 and see update and what happened in here, after which reset bars and then click on interactive design. You see it has passed now 4y25. Click on the OK options and then OK. So this is how you can tackle those of your columns that have failed design successfully. So you can see this one is also failed. The same thing you have to do to this ones. Okay, so for instance, let us check this one right away. It's a lot of reinforcement there. What is the issue? It should be the section problem. So let's increase the sections to 300 right there. Update it. Okay, click on the design and see. Okay, so this may pass the design successfully. I think this has passed this design successfully. Click on the OK and see what happened there. So it has passed the design. U ratio is 0.99, which is very close to 1, meaning the column is carrying more of more of load. Okay, that's why you see the U ratio you see here. It is used to determine the column that is carrying more load and the one that is carrying less load. The one that is 0.9 is carrying more load than the one that is 0.32. You get? So you can see there. So you can also increase this section again. That sections of 99 can also increase it. So once you increase the section, you see the ratio going down because the column is now having the capacity to be able to carry the loads that is coming on it right there. So this one, the same thing. You have to check it. What is the issue? Okay, it's the same thing. Section is sufficient. Okay, so you just have to increase this. You can first try to 50 during your design. You update it, reset the rebars, and then interactive design. Okay, this has passed to 50, has passed this. So you can see, click on the OK options and then to have that. So the same thing applicable to all of this. We will not be able to do all of this, okay, for now. But that is what you will be doing to all of these columns, okay, that are actually showing this failure sign. Okay, so having done that successfully, we have to close this dialog. So the next thing we will be doing, we'll be looking at this reinforced concrete slab design. Okay, so we have to navigate to the slab right here. We have to navigate to the slab right there, and then we have to navigate to level 1 and then enable the plan view of that. So we have this. So for our slab, we are going to be drawing our slab strips, and then we'll be using analytical strips. Okay, so we navigate to the modeling tab right there, and then you see slab strips here. Click on it. All right, so at first you have a slab strip dialog just like this. The general is for only the analytical slab, but we want to use finite elements slab strips. You just have to select finite element and then come over to where you have FE tab here. So this place will be enabled. Okay, maybe we may have that in another lesson. Okay, so having done this, we see these provisions. This is bob, meaning we are starting outside slab and ending outside slab. Okay, this one simply means inside slab. So you have to be interchanging these provisions as you are drawing the strips. Okay, so now the first direction is the x direction. We are going to be drawing the strips, so you have to get it selected first. So you are going in the horizontal direction, so we'll pick this point to draw a strips over this, and then hold the control key to have a straight line just like this, then click. So once you click there, you will notice that the strips is not being drawn. Okay, so let's do that again. So before you do that again, I want to explain to you why the strip was not drawn at first. The reason is because we are having an expansion joint here. So we are supposed to start the strip from here. So it is active now. I have to click here to start the strip from here, this point now. Then I'll take it this way because there's an expansion joint there. Okay, so I will hold the control key to have a straight line like this. Then I will release click to now see the strip drawn, okay, in the x directions, just like this. Can see the strips, okay. Alright, so the same thing we'll draw in the other way around. So you zoom closely, and then you make sure you pick right between this expansion joint. This is 25 millimeter. It's very tiny expansion joint space. Okay, so come over to this side, hold the control key to have a straight line, and then you click on that point to have the strip drawn in this particular panels of the slab. Okay, so the same thing you are going to do in this horizontal axis for all of these panels successfully. Okay, so having done with the strips in the horizontal direction, you just have to click on the Y provision there for the Y directions. Okay, and then you start to draw the strips. Okay, zoom closely, pick the first point, take your hand over it, hold the control key, and then click to have that strip drawn just like that. In that panel there is a small panel here too, so you click here, you have a horizontal vertical strips drawn just like this. Okay, the same thing here. Sorry, that is wrong click. So you pick this point, and then you draw your strips just like this. So we have done drawing the strips in both the vertical and the horizontal. You can see this is top bar. Okay, also we have a top bar and the bottom bar all being level just like this. Okay, so this is for the first floor. For the second floor, since it's the same thing, we are not going to be drawing strips here, so rather we'll be using this one, okay, to replicate the other ones in the second floor. Okay, so after which you have to design the slab. Okay, the slab, select it, right click, and then come to come to slab analysis and design, this one. Okay, so not ordinary drawing a strip. After you draw your strip, that is when you now have to carry out slab analysis and design just like this. You click on it, so you have all of this. You select delete and reselect all bars. You can use these options, or you can use check design only, reselect insufficient bar, so it will also carry out its functions. But then use that one, click OK, and then give the program some seconds to be able to carry out the analysis and design of the reinforced concrete slab. So that is done successfully. Okay, so as you can see, this one is the report. Okay, this is the slab strip report. Okay, the slab strip reinforcement report. You can see the insufficient sufficient here. This place is sufficient, telling you the strips like the rebars provided is sufficient. Yeah, okay. Deflection check, you can see it over here. All right, so you can print this, and this is your slab report. Okay, using PDF or Office right there. So let's close this for now. So we have designed the slab successfully. You can click on the cancel since we have done that effectively. All right, so the next thing we will be looking at is the foundation design. The foundation design. So for us to design our foundations, we need to navigate to the story 0 right there. So where we see the columns here. Okay, so here is the columns. So for these columns, these one that are combined footings, they are going to be combined at the foundation here. So what we do is this one that has a expansion joint, we are going to combine it. So you get the two selected like this, right click, and then click on the insert combined part footings. So you can select that, and then you give the program some seconds to load the foundation designs dialog options. Okay, so you have it here loaded successfully. So you can see we have 2000 and 2100 AY and LS. Okay, so these are the sections, okay, of the reinforced concrete. So you can make it a square sections by increasing this 2000 to 2100. So we have square sections. You can also see the 3D over here if you have to hold it. Okay, left click, hold, and then rotate your hand. Okay, you can see there's a reinforcement, and now you can see it is top and bottom. All right, so I will show you how to get rid of this top and bottom. So you can come to rebar here, you come to rebar and remove this top here, so we don't need tops there. Okay, so as you are removing, you have to be checking all of these provisions to make sure they are all okay. If they are not okay, you should know that yes, you don't have to remove it. So since now they are okay, there is nothing wrong with that, everything is fine. Okay, just like this. So we have successfully designing this for only single bottom reinforcement and not double top and bottom. You can see, click on the OK options right there to insert these footings here. Okay, just like this. All right. So the same thing we are applicable to this. For us not to observe that top and bottom reinforcement, there's a setting we need to go and do, which we are going to be doing right away. We have to navigate to the building set out, and then you come to the setting center. So in this setting center dialog, you have to navigate to where our foundations. Okay, so come to these foundations. Okay, so general right there. So in this general, remove this, uncheck this, this, and this. Okay, this is just what we need to uncheck. Click on the OK options, right? And then now save the project. So now we save the project. Let's try it and see if we have a double footings right there. Select the two columns and then use combine footings. Okay, mind you, this is Protastructure 2021 I'm using for the design. Okay, so you notice that design has failed. Okay, design has failed. This is giving us quite a very large sections, and this has actually fair design over here. Okay, so provide the reinforcement here has actually make this design to fail. So you calculate again. So what we need to do is, in this case, you have to either increase the depth. Yeah, this is 500 depth, so increase it to 600, the depth of the footing. So you see design has passed now by increasing the depth of the footings to 600 from 500. So let's try 550 and see 550, and then you click on the you don't need to click on design. So once you change it and click in other provisions, it's going to design and check itself successfully. So now we have a past footing design. Now come to the 3D. Let's see if we have a double. Therefore, see we have the single now. It's now single because we have already set it. Okay, so at this point, click on the OK option to insert that. Alright, so having done that, for these other columns, you can be able to select all of it just like this. Get all of the columns like this selected. So we can insert the part footings at once. So we are going to consider insert part footings. Okay, this time around, select that, and then give it some time. It's going to design all of the part footings just like this. Okay, so design is still in progress. All right, design is still in progress. So you just have to give it some time to design. So you can see it's been designed successfully, and then some of the footings are actually failing. Okay, this one has failed. Okay, this is 2.5 by 2.5. All right, so and then about 2 of it has failed. So you have to take note of the one that have failed. Okay, so what you need to do now, click on the design all, select this one to design all, and then click on design again. Let's see what happened. So give it some time. Okay, so it has been designed all the footings. Still this one and this is also having issue. So let's increase this footing depth. We have to 600, and then click on OK. You see it has part design. Okay, it has part design 600. Let's make it the footing depth to be 550 right there. It failed design. Okay, let's make it 600. I think 600 is okay. Right, that's past design. Okay, okay, let's check here again. 600 pass. Okay, so this one, let's make it also 600. All right, passed. All right, so this one, let's make it also 600. All right, so that has past design. So almost all the footings now has past design. So the footing sizes differs, as you can see, depending on the load that is coming on it. Okay, so this is how it's supposed to be. All right, so everything is good now. At this point, you just have to click on the OK to have the footing inserted successfully. So you give it some time, it's going to create the footings just like this. You can see. So we now have our footings being placed successfully. The same thing we have to do in this other provisions in this site. So we get to select all of this as well. Okay, right click and then you select insert part footings right there. Then you give it some time. It's calculating. It is calculating. It's going to calculate and design all the footings together just for some seconds. Alright, so design is done. Okay, some of it are also failing. So the same method, just increase the depth of this, make it 600. Increase the depth of this, make it 600. It will all pass. Okay, so it's actually punching. That is why it's punching. So you have to increase the depth of the footings to avoid that punching. Okay, so everything now is good. Now everything as per design. Let's try to scroll down and check. Okay, this one is also, these two are failing. These two are failing. So you just have to navigate. This is the one, and then change it to 600. Change it to 600. And then the next one is this one that has passed, and then change this one to 600. This one 600 did not pass, so let's check. Take it to be 650. It still not pass. Okay, let's just increase this and then increase this. This is quite large. Okay, all right, that particular column is actually not passing, but we'll take note of the column. Okay, FC1C26. Okay, so we'll take note of that when we work on it independently. So after which, what you need to click on the OK options. So it's going to install the footings for us, just like this. All right, so for these other places, we just have to install them manually. Okay, so now you see we have done with the foundation design. Let's navigate to the 3D to see what we've done so far. All right, so you can see here, so we have actually carried out the foundation design. Okay, the foundation seems to be transparent, so if you want to make it solid, you can navigate to where you have layers right there. Scroll down to foundations. Okay, you scroll down to foundations. Where is it? Yeah, see foundation ash, footing ash right there. So you have to take this up, the opacity, increase the opacity, and then you can also change the the color of the foundations. Okay, so let's use this one. Okay, or we can't also use any of this. It will be fine. Click on the OK options to have a solid footings just like this. Okay, all right, so we are done with the design successfully. We have carried out modeling, we have carried out analysis, we have carried out design. Okay, so the next thing you will do in this structure now is to now carry out interactive design on your beams. Okay, you have to carry out interactive design on your beams, first floor beams, second floor beam, and the roof beam. That's the next thing you will do. Okay, so I want to show you how to carry out interactive design on your beams. Okay, so after I must have done with the interactive designs, the structure is now set to be transferred to Prota detail for structural detail drawings. Okay, but we have to carry out interactive design for all the beams. So how do we do interactive design for all the beams? You will have to navigate to let's go to the setting out, and then we need to select the beams. Okay, let's say we'll start from the first floor beams to do the interactive design. So I will navigate to the story one, which is the first floor beam, this one, right click, and then I will click on ROC beam design artist story. So this will give me the beams of the first floor only in a dialog. Okay, so you will have the beams like this. Select it first, this one, and then you have to click on the interactive design. Now I want to show you what you want to do, what you have to do to this beam. Now if you see this beam now, this is a continuous beams, and at the support is still having a reinforcement. So what you need to do, you don't need the reinforcement except it is failing at the support. That's when you need the reinforcement. So you just have to extend this one, get it selected, and then you see extend right to short. You have to lap it like this, and then this other side. So after having extended this side to the support, you come to this other side, select this 2y16, and then select here, lap it that way, lap it that way. So having done this, you have strengthened this support. Okay, so maybe let's try to reduce this to see. You will notice that this second layers of support is not functioning again. So you click here to the first layer of support, click here to make it support by making it a dotted line like this. So when it's a dotted line like this, means it's a support bar to this particular top bar. All right, it's going to be supported by providing spacer. Okay, so let's reduce this. Okay, you see, if you reduce it, it's failing already, so you increase the limit at 25. So you can see the length of the span of the beam, which is 7.05 meters. Okay, here is 7.3. Okay, so that is why it is selecting this high diameters of reinforcement. So you have to do the same thing here. Lapped it over there, also lapped it over there. Then try to reduce here. Okay, and then increase here. Then reduce the reinforcement. Reduce it. 16. Reduce it. Okay, reduce the bar here. Okay, it's failing. You can use 316, but make it a second layer, just like this, like a second layer. Click in this drop down, select second, just like this. You see it failing, increase it to 20, it has passed. Okay, so this is how to carry out interactive design. The same thing applicable to this one. You have to also lap it. Okay, that side, then try to make this one second layer. All right, then try to reduce the diameter of the rebars as see. Okay, make it 320. Okay, all right, so now this is how you will edit and interact with your beam successfully. Okay, over here we are having 225. Okay, so you can try to reduce this. You see it's failing. All right, so you can decide to choose 320 it has passed, and then try to use 320 in all of these provisions to see if it actually passed. Okay, here is 16, can go 316. Okay, just like this. Here is 20. Here is 25. Reduce it and see it's first there at the bottom or at the compressions. All right, so you just have to make sure that all of this is being edited just like this. Now this beam now is very okay to be printed out. All right, it's very okay to be printed out. So you click on the OK option, but before you click on the OK option, I want to be showing you another setting that you need to do. Okay, so you come to where you have go to this provisions, beam details. No. All right, click on the OK options. Let's pass through another way to show you that. Click on the OK. So what I've done to this beam now is what you are going to do to all of these beams. All right, once you are done with it, it means the beam is set to be printed out. Now over here, come to settings and parameters. In the settings and parameters, come over to where you have the details. Okay, containment. Okay, this drawing details. This one, come to general, and then come to where you have beams. Also select sections. Now you need to pick only one section and not 3 sections. All right, so after getting the one section selected, you get to select the first restart sections label in every axis. Pick here. All right, you are trying to prepare your beams for detailed drawings. Okay, so come over to where you have this. Instead of having your beam presented in these sections, you need to remove these structs annotations to have it just like this. So this is best presentable. All right, so we can print the total links using these provisions as well. So these are the necessary settings you have to do. After we click on the OK options, and then you closed this dialog, then you save the project first. After having the project saved successfully, what you now need to do is to generate your drawings, okay, through Prota details, which we are going to be covering in the next presentations. And so if you want to have a personal training on this program, a link in the description of this video where you can reach to us, and we will train you professional level and up to advanced level, even from scratch, from 0 to hero in Protastructure. We will train you, and then you will become guru on your own. And so if you want to actually view the details of the beams, you can see them here. You see we have a story beams elevations. If you click here, you will see the beam drawings. So let's just click it and be able to select. We just want to look at a beam drawing for story one only. Click on the OK options, and then you give the program just some seconds to generate those drawings for us. So you can see all the drawings has been generated just like this. So this is the section presentation that we have set. So once you export to put that detail, this is what you will be having. This is just a kind of preview of what you have done so far. So you can just close it right away, and then we get back to the 3D right there. Okay, so we stop here. Don't forget to like the lesson. Don't forget to subscribe to CAD level 100, as we will be bringing an advanced lesson of this kind to you almost every week. All right, and so in the next lesson, we'll be taking this whole of this structure to Prota Detail to generate the structural detail drawings of this, and then from Prota Detail we'll take it to AutoCAD, and then we'll be able to edit this drawing in a way that it will be presentable and then printable. Okay, stay tuned, stay connected, and stay safe. Bye for now.